A blessed good day to you. I am T-shirt Daily Reese with New Birth Apostolic Deliverance Ministries International, and boy, do I have a question for you today. Can we prove by science that there is a God, that there really is a creator of the universe, of the world, of us? Well, I want you to consider this question. Do you agree that mathematics is the product of a mind? Pretty sure that you can agree with me that equations are the product of minds. Algebra doesn't just happen by itself, okay? It takes a conscious mind to come up with it, right? Would you also agree that information is the product of your mind? That meaningful information, codes, messages, all these things are products of the mind, correct? So if you're walking on this seashore and you see "I love you" written in the sand, you're not going to suppose, well, maybe the waves of the sea naturally just cause ripples to form in the sand and made the word "I love you." You're going to think that some conscious, intelligent being wrote "I love you" in the sand. If you hear Morse code coming at you, you're not going to think that that was random either, because there's a specific sequence that shows intelligence. So again, we know that where there is information, meaningful information being transmitted and received, translated, where there are codes to be decoded, we know that it takes an intelligence behind all of this. And I want to point out the fact that there is indeed a tremendous amount of information in nature. In fact, notice what we have in terms of our DNA, and this is from the site Evolution 2.0, and it asks the question, is DNA a code? And here's what we find. Code is defined as the rules of communication between an encoder, that's a writer or speaker, and a decoder, a reader or listener, using agreed upon symbols. DNA's definition as a literal code, and not a figurative one, is nearly universal in the entire body of biological literature since the 1960s. DNA code has much in common with human language and computer languages. Now, those of you who are into information technology, you would find this interesting. DNA transcription is an encoding-decoding mechanism isomorphic with Claude Shannon's 1948 model. The sequence of base pairs is encoded into messenger RNA, which is decoded into proteins. Information theory terms and ideas applied to DNA are not metaphorical, but in fact quite literal in every way. In other words, the information theory argument for design is not based on analogy at all. It is direct application of mathematics to DNA, which by definition is a code. So what I'm saying is that there is mathematics in your body. There is mathematics in your DNA. You didn't put it there, but it has to be the result of an intelligence. Notice the direct comparison between communication systems in electrical engineering and the DNA communication system. What you have here is the map from the mathematical theory of communication. Okay? Now this is Claude Shannon's communication model from the Mathematical Theory of Communication, University of Illinois Press, 1998. And we have here the information source, and the message is going to a transmitter, and then a signal is going out, and you have a noise source that interacts with that signal, and from there the signal is received by a receiver and the message goes to a destination. Now if you compare that to the model for how DNA transmits information here, you have Hubert Yockey's DNA communication channel model. And notice that it contains the same exact components as Shannon's. The two systems are isomorphic. They're the same. So The thesis being offered here is that communication systems of this type are always, without exception, products of design. Now, this is taken from Hubert Yockey, Information Theory, Evolution, and the Origin of Life, Cambridge University Press, 2005. This is impressive stuff, okay? This is not coming out of a corner. This is not coming out of a church. We are talking about Cambridge University here. And notice that the transmission system of DNA is even more complex than the transmission system for the information in a computer system. That's incredible. So what you have here, if I can enlarge it a bit, you have the message in the DNA alphabet. This is like the source tape or DNA tape, and that goes to the encoding region. So you have DNA alphabet to mRNA alphabet. Transcription happens here. And then you have this channel where the message is being sent. Again, remember the noise. Then you've got noise, but in this case, the noise is coming from multiple locations and not just one. And that's a point of mutation. And from there, the message is being transferred over to the decoding region. It's received by the decoding region, and you've got a whole set of other stuff going on with these amino acids, okay, transmitting their noise to the decoding region. And from there, it goes to the protein message in the protein alphabet. So this is an even more complex mechanism of communication, but it follows the same pattern. It follows the same method. So I think that this is very powerful stuff. The author says, I define coded information as a system of symbols used by an encoding and decoding mechanism which transmits a message that is independent of the communication medium. Examples of code include English, Chinese, computer languages, music, mating calls, and radio signals. Codes always involve a system of symbols that represent ideas or plans. Notice, they represent ideas or plans. Other examples include, yes, bee waggle dances, bird songs, whale songs, and ant communication by pheromone. Since all the above are derivatives of DNA, you know, this is mind-boggling stuff, because when we think of your DNA, what you're actually thinking about is the blueprint for the entire human body. But again, a blueprint is by definition a plan, and a plan by definition is information that comes from a mind. So how on earth is it possible to have information in nature without there being a mind? If you even look at the definition of the word information taken from Wikipedia here, the English word information apparently derives from the Latin stern information of the normative informatio. This noun derives from the verb informare, to inform, in the sense of to give form to the mind. That's what information means, to give form to the mind, to discipline, instruct, teach. All of these things are personal. They involve a personal conscious agent. Inform itself comes via French informer from the Latin verb informere, which means to give form or to form an idea of. So we are speaking of concepts. We are speaking of ideas. Okay? And this is very powerful stuff, because you know, when we think about everything that is going on in the human body, when we think about the very nature of information itself, it seems to consistently point back to an intelligence of some kind. But then, if there is an intelligence that placed this information there, it can't possibly be a human intelligence, because we know that DNA was around even in the animal kingdom before human beings existed. So this should tell us that there has to be a God who placed this information there. Remember how we started with mathematics and we asked the question, is mathematics the product of a mind? Okay? Is mathematics the product of a mind? Now, I want to show you something very fascinating that I think will help here. Now, this guy, Roger Penrose, is a British mathematician, a mathematical physicist, a philosopher of science, and a Nobel laureate in physics. This guy won a Nobel Prize for his work in physics. He is Emeritus Rose Bale Professor of Mathematics at the University of Oxford, an Emeritus Fellow of Wadham College, Oxford, and an Honorary Fellow of St. John's College, Cambridge, and University College of London. So here's a guy who obviously knows what he's talking about. And notice what his religious views are. It says here, during an interview with BBC Radio 4 on 25th September 2010, Penrose stated, "I'm not a believer myself. I don't believe in established religions of any kind." He regards himself as an agnostic. However, in the 1991 film A Brief History of Time, he also stated, "I think I would say that the universe has a purpose. It's not somehow just there by chance. Some people, I think, take the view that the universe is just there and it runs along. It's a bit like it just sort of computes, and we happen somehow by accident to find ourselves in this thing. But I don't think that's a very fruitful or helpful way of looking at the universe. I think that there is something much deeper about it." So he himself recognized that the universe has purpose. But something can only have a purpose if it has a creator who gave it such purpose, who put it there for a reason. I want you to hear Penrose himself, though he is agnostic, though he doesn't believe in God, though he's not a Christian. This is not some biased source that I'm citing. This is not some church theologian I'm citing in support of the Bible. Okay? This is an academic, professional mathematician, top of his field, who has won a Nobel Prize for his work in physics. Okay?
Roger,
telling
I have
us
been fascinated by mathematics my entire life, and
that the
it's a pleasure to
universe
come
is
to you
built
to discuss
upon a
two
mathematical
of its fundamental
structure.
aspects.
Listen
One
to what he
is
says
incredible
about it.
capacity to describe reality, and then what mathematics really is. So let's start with the first. How accurately does math describe the physical world?
Well, it is extraordinarily precise. And in different areas, more precise. In some areas, we know less about it. But I think people often find it puzzling that something abstract like mathematics could really describe reality as we understand it. I mean, reality, you think of something like a chair or something made of solid stuff. And then you say, well, what's our best scientific understanding of what that is? Well, you say it's made of fibers, cells, and so on. And these are made of molecules, and those molecules are made of atoms. Those atoms are made out of nuclei and electrons going around, and then you say, well, what's a nucleus? And you say, well, it's protons and neutrons, and they're held together by things called gluons, and their neutrons and protons are made of things called quarks, and so on. And then you say, well, what is an electron, and what's a quark? And at that stage, the best you can do is to describe some mathematical structure. You say, things that satisfy the Dirac equation, something like that. But you can't understand what that means without mathematics. I mean, mathematical description of reality is where we're always led. And these equations are fantastically accurate. The Dirac equation, which describes the electron or quarks, is a very precise equation. And for example, there's a calculation which describes the magnetic moment. That is, electrons behave like little magnets, and the magnetic moment, the strength of that magnet, can be described in terms of other parameters. And there's a calculation which gets the accuracy of that. Well, Feynman had a very good description. He said it describes the distance between New York and Los Angeles to an accuracy of less than the thickness of a human hair. So that's pretty precise.
That's unbelievable. And that's describing the microstructure of atoms and
But these are the particles.
the electron and the gluons.
The electrons.
Quarks.
This is specifically electrons and quarks, the things which are called spin half particles. But don't worry about that. Gluons are slightly different.
Now, mathematics can also describe things in the ordinary physical world, gravitational attraction, electromagnetic attraction, and with the same kind of descriptive accuracy.
Well, there's another, even more in a certain sense, because gravity, according to Einstein's theory, Newton's theory already had a precision of something like 1 part in 10 to the 7, so that's 10 million.
Wow.
1 part in that, and then there was discrepancies seen in the behavior of Mercury and so on. And that's where you start to see differences with Newton's scheme. And then Einstein comes along and produces a theory which is now known to have a precision something like 10 to the power 14. And that precision is a measure of how accurate. There's a particular system of 2 stars going around, special kinds of stars called neutron stars, very dense objects. And these stars, one of them is what's called a pulsar. It emits pulses of signals which can be timed extremely precisely. And over a period of, well, I suppose it's maybe more than 30 years now, I can't remember, they've been observing this thing. And in that period of time, the accuracy over that length of time is known to something like 1 part in 10 to the 14.
Wow.
And that the accuracy, the agreement between Einstein's theory and the observations. So it's telling you these are very, very precise theories.
So whether we're talking about the structure of very large entities, neutron stars over great distances in the universe with gravity, or the structure of an electron,
That's right.
mathematics in both cases is able to describe it with that kind of incredible precision.
Exactly. Yeah.
And these are small equations. I mean, they're not giant.
That's right. They're relatively small equations. I mean, they're a little difficult to understand. Einstein's theory is certainly subtle. It's not complicated in the sense that the ideas, you have to understand about curved space and that sort of thing, which is not an easy thing to get your mind around.
But once you get over that...
But once you get over that, it's about the simplest thing you could write down.
Wow.
In that kind of term.
So we have this extraordinary precision between mathematics on the macroscopic level with neutron stars and at the microscopic level with the nature of the electron. And mathematics incredibly precise in both cases. So what does that now begin to tell us about what mathematics really is?
Yes, well, in a sense, this is telling us that our picture of physical reality depends on something, in a sense, which is more precise, at least in our understanding of it, than how we think about the world. And this precision really dates back to the ancient Greeks, the time of Pythagoras, later, where they developed the mathematical ideas as a field of study, stimulated to some degree by physical reality, because the geometry of Euclid, which was very much part of the mathematics that was being studied then, which we now know isn't extraordinarily precise. I mean, it is extraordinarily precise, but it's not as precise as Einstein's theory, so one has to go a little bit beyond the geometry that they had. I don't think they quite appreciated that they were doing physics, because they didn't realize that the geometry of the world could have been anything else. But they developed this mathematical scheme purely as a study on its own. And so mathematics was studied as a pure intellectual activity, and without necessarily it being related to the structure of the physical world, although geometry clearly was a big input. But then the properties of numbers and how you add and multiply, and the notions of prime numbers, the fact there are infinitely many prime numbers, that goes back to Euclid and earlier. And so these things about numbers were developed very much from the time of the Greeks. And ever since then, mathematics has been a subject which you can study for its own sake. It has its own life, in a sense. Certainly mathematicians view it this way, as something out there which seems to have a reality independent of the reality, of the ordinary kind of reality, like things like chairs and so on, which which are what we normally think of as real. But, okay, the mathematical reality is something different. It's sometimes referred to as a Platonic world, Platonic reality. And sometimes people have a lot of trouble thinking of that as real, and philosophers worry about that and so on.
What would that mean, a Platonic reality?
Well, I think it's a different kind of reality from the reality of the physical world. I mean, I tend to think of there being different ways of looking at reality. There's the reality of our mental experience, which, okay, interrelates with the reality, physical reality, but so then does the mathematical reality of this Platonic world, which gives reality to these notions. So if you like, mathematical facts, like there is no largest prime number, is it's something independent of ourselves. It's always been true. It didn't somehow become true as soon as somebody saw how to prove it. It's always been true. There are wonderful examples like
And it would have been true if nobody ever
nobody had been
proved
around.
it.
Exactly, yes. And in a sense that had to be so, because if the physical world depended so precisely on these mathematical laws, I couldn't have known what to do in a certain sense if the mathematics hadn't already been there. I mean, it's not us that imposes this on the world. It's out there. Sometimes people think that, maybe the reason we have good mathematical laws of physics is that's the best way we can come to understand the world. But it's something more than that. It really is out there in the world.
Well, that's the argument. Whether mathematics is invented by us, by human beings, trying to impose our way of thinking on the physical world, or whether it is discovered because it's already out there and we're finding it because it's already there. Those are the two polar views.
Sometimes people do argue. They say, well, it's just our way of organizing the what we see about us. But I really don't think that's good enough, because Newton, for example, the observations probably had about 3 figures, 3 decimal places. Yeah. And he produced this theory which kept on working till about 7 figures, you see. Then there were discrepancies, see. Einstein produced his theory mostly out of his head, with appealing to things that were known to Galileo and so on. But apart from that, it was not much more empirical evidence. But he produced his theory, which extended far beyond anything that the observations at that time told us about. And they keep on agreeing with the observations. So that theory, which is, if you like, a Platonic absolute thing, it's a mathematical thing, seems to be inbuilt into the way the world operates. It's not as though you see a new effect and say, okay, we're not going to think of a better theory to accommodate that one. Sometimes science is like that. But these really good physical theories are not like that. You're revealing something in the way the world operates, which is there all the time. And I don't think there's any way of understanding that just in terms of our trying to understand what we see around us.
A critical fact really seems to be what you said, that when these mathematical theories were discovered, the accuracy that the observation that they had at the time was small compared to the accuracy that those theories then produced.
That's right. I mean, Einstein's case, okay, 7 figures of decimal were known perhaps in the planetary motions.
Yeah.
But there's another 7 out there. The precision is over and above that. Is
10
as
million.
Much as, yes. It's
10 million, 10 millions.
It's 10 million, 10 million, 10 millions. Yes, that's right. Yes.
I mean, that's unbelievable.
Yes, no, it's incredible.
So push it further. What does that mean? Because mathematics is almost infinite in terms of all the different relationships and expressions and things that we already know.
Yes.
What does that mean in terms of how much mathematics is sitting out there?
Well, that's a good point, because there's an awful lot of mathematics which doesn't seem to have any clear relation to the physical world. The way I like to picture it is there is this world of mathematics, and only a small part of that, and it's a very fruitful part, it's an extraordinarily fruitful part, has relevance to the physical world. There's an awful lot out there which, as far as we know, has no relation to physical behavior.
Well, of course, people said some of that in the past, and then we've been surprised to find some other things that later had. But still, there's so much math out there, then so much bizarre,
That's right.
I don't know how else to put it, structures that it would seem impossible that could relate to the physical world. But what does that mean about if it is out there in some platonic world? What is out there? In other words, all these infinite ideas and structures and possibilities.
Yes, well, sometimes people think of these as mental creations, you see, but it doesn't really explain. I mean, there's this wonderful example of the Mandelbrot set, extraordinarily complicated.
The fractional.
Yes, and you can magnify little bits of it, and you see all this incredible detail, and that's all there in a very simple mathematical idea, and it's encompassed by this very simple piece of mathematics.
How does that give your own sense of what mathematics really is?
Well, I think there are two aspects to mathematics, at least how I look at it. Some people are just exploring the mathematics, and that's their real interest, and it's the beauty in the subject often, and that's why they're doing it, because they find it exhilarating, something they find really wonderful to do. But there's the other side of it, which is how it relates to the physical world, and there is this extraordinary precision that we find. When you get the mathematics right, it really mirrors the behavior of the physical world to an unbelievable degree. So there's these two sides to mathematics. It has this reality which you can study quite independently of its role in physics, and the other side, which is how it really does seem to reveal how the real world operates, in a certain sense what the world is, as far as we can understand it.
So there you have it. Mathematics is not invented by us humans. It is discovered. And here is one of the world's leading chief mathematicians telling us that this is the case, that mathematics is out there, that the entire universe, from the smallest atom to the largest star, was built on a mathematical framework, on a mathematical structure. So what is this saying? It's like if you find a house and that house has a blueprint. The house was built on the guidelines or the structure of that blueprint. Clearly, the blueprint required an intelligent mind. The computer works according to the computer programming, according to the algorithms, to the algebra equations that are put in to the computer system in order for this thing to work. And it's the same with the entire universe, from our DNA to our cells, to the atoms, to the orbits of planets, to everything in the universe. They operate according to the laws of mathematics. And these laws, whether it's the speed of light, E equals mc squared, energy equals mass times the speed of light squared, whether it's the strong nuclear force, weak nuclear force, the strength of gravity, and so on and so forth. We could go on and on. There are all laws of physics that are following precise mathematical formulas, equations, which require an intelligence, which require a mind. Whose mind did all this math come from? If not the mind of an omnipotent God who created the universe and everything in it. So I'm saying to you today that since we have scientific data showing that such a being exists, showing that there is indeed a creator who created the universe for a reason, that the universe has purpose, okay? It means then that our obligation is to seek out this creator, because we must be here for a reason. And so one would want to know, how does the creator speak to us? Has he revealed himself to us? Do we have access to the mind of this God? And so my challenge to you then is to seek him out. If he exists, then there must be a way to find him. And if indeed there is a creator who is responsible for this mathematical framework upon which the universe is built, then we have to be open to the possibility of miracles. We have to be open to the possibility of angels and demons and healings and prophets and all the rest of it. Because the whole concept of a God, the whole concept of a creator who created this vast, incredible universe is even more incredible and stupendous than believing in talking snakes and miraculous healings and that kind of thing. The whole concept of a divine creator who put this entire universe together is far more incredible. So I hope that this has been a blessing to you. I'm Minister Daley Reese with New Birth Apostolic Deliverance Ministries International. God bless you.